Hello everyone. Today let's look at how to speed up the memory allocation and deallocation in C++ using a C++ memory pool. So to explain the scenario here, we have some data. So in this case it is 4096 bytes, and this no pool function which recursively allocate and deallocate this memory using the system new and delete operators. And I'm doing this a lot of times in this for loop, and I'm printing the elapsed time for this no pool function here. For the second scenario, I have some global memory location which is shared, and I have overloaded the new and delete operator, and this new operator is returning the just the pointer to the global memory location, and the delete operator does not deallocate this memory. So, and in case of this this is a simple memory pool example, and so I'm just in this for loop I am creating this new shared data instead of data. Okay, so let's try running this and actually benchmark the performance differences for both cases. So yeah, so you can see the elapsed time for this no pool case is 79 millisecond, and in case of this simple memory pool example where we are only doing one allocation is 3 milliseconds. So yeah, it's almost one order of difference in case of the time taken for allocation and deallocation. So this is pretty much exaggerated example here, but nevertheless it is a significant difference. So why does it happen? Well, the reason is that whenever you call a system new operator, the compiler has to figure out where in the memory location is actually a free memory available and return that location to you. So in order to speed this up, instead of allocating 4096 bytes for every new operator or delete operator, in the first time when we are going for allocation, why not just allocate a large chunk of memory, and then from that chunk of memory reuse the memory for subsequent allocation and deallocation. So this is the idea behind a memory pool. So let's try to implement our own memory pool in C++. So here is my class for a memory pool. Here we have a convenience struct unit. So a unit is the atomic memory unit of this memory pool. So and it is just a doubly linked list of this unit. Okay, so then we have a pmem block, which is the base address of our memory pool, and we are going to have two linked lists. One is the linked list of allocated memory units, and next is a free linked list of the free memory units available. And then we have our unit size, which is the size of one memory unit, and block size, which is the size of the whole memory pool. So in the constructor you can see we have two arguments, the number of units we have and the size of one unit, and then from that the block size is computed like so, where it is number of units multiplied by unit size multiplied by the size of this convenience class for our doubly linked list. Okay, so in the constructor, as you can see, this is the only memory system memory allocation we are going to do. We are going to call malloc over this block size. So that is going to speed up our memory allocations a lot. But one thing to notice here is that if the block size is too big, then this malloc might fail. So you have to give reasonable values of unit size and unit num to make sure that the malloc won't fail. Okay, now in the constructor I'm just creating this free linked list, and the so you can see that after mallocing this much memory, I am making chunks of units out of it, and then just attaching them, populating the previous and next pointer of this free linked list. Okay, now in the destructor we are only going to deallocate this memory once. So when our memory pool get destructed, we are going to free this memory allocated in this malloc. Okay, now coming to the custom implementation of our allocation and free functions, let me head over to whiteboard to first explain you the how we are going to move around the nodes in our linked list, in our free and allocated linked list, in the alloc and free functions, and then come back to the code. So we are going to have two linked lists, as I mentioned, the allocated and our free linked list. So in the constructor, we saw that the free linked list get created. So for example, here let me take 4 units of memory getting allocated, and now let's say an alloc call happens. So then what's going to happen is that we are going to remove one of the allocated units, one of the free units of memory in the free linked list, and we are going to put that in our allocated linked list. So if there is another another alloc call, then another unit gets picked from the free linked list and will get added into the allocated linked list. Okay, now what happens when a free call happens? So in case of a free, one pointer will be given to us telling which memory address in the allocated linked list we should free. So let's say we are freeing the second unit of memory in this allocated linked list. So we are going to remove it, and we are going to put it back into the head of add it to the head of our free linked list. So one more example is, so if you free again, so we are going to free here and then put it back to our free linked list. So coming back from the whiteboard and into the code, we can see the alloc function. First we are checking whether the unit size that is given to us to allocate is greater than the unit size of a memory pool or not. If it is greater, then we are going to use the system malloc itself. But if it's less and we have free memory blocks available in our free linked list, then we are going to use the logic that I mentioned in the whiteboard here to allocate one of the units from our free linked list and give it to the client. And in case of free, we are first given a pointer to one of the memory units, and we are first checking whether this pointer belongs to our memory pool itself. If not, we are going to use a system free itself. Otherwise, we are going to have the logic that I mentioned in the whiteboard, wherein we are going to pluck that the unit that the pointer p points to, and from the allocated linked list move it to the free linked list. So that's how a memory pool works in C++. So here is how we are going to use it. We are just going to initialize this new memory pool given the unit number of units you need and the unit size. So I'm to reiterate here, only one system allocation will take place, where 4 into 32 plus the pointer size. So where the size of this struct linked list is also there, so there is a small 2 bytes also. So this much memory allocation will happen in one go, and then you can call this alloc and free functions of a memory pool to do subsequent allocation and free operations. and then you only have to delete pool, and this much memory will immediately be deallocated here. So only one system deallocation will happen. So I hope you guys found that informative and enjoyed the video. Thank you guys. See you on the next one.